Welcome to the Leantec robot training video. This video will demonstrate how to operate our Leantec robot. In this video, we will introduce our latest panel buttons on our robot controller. This video will also demonstrate the basic operation of a Leantec robot, such as the joint and endpoint movement and the types of coordinates used by our robot arm. Let's get started. The picture shows our robot controller, or it's better known as the robot handheld teach pendant. The front section consists of three main components: the screen display, the emergency button, and the panel button. The enabling device can be found at the back side of the teach pendant. It functions as a safety switch to avoid unintended movements of the robot arm. Press the enabling device halfway down before pressing the start button. Pressing the switch all the way down will reactivate the safety feature and the arm won't move. Now, we are moving on to the introduction of the panel buttons of the Leantec robot arm. Our latest design of the panel buttons aims to provide a simpler and comprehensive teach pendant to the users. That is to say, our existing user won't undergo that much of a hassle to master it. The execution keys are placed at the top row. They're basically the buttons that controls the course of a program. To reset the program back to its initial status, press the reset button. Pressing the start button will execute the selected robot program, while the hold button will stop the program from being executed further. Activating the auto mode will switch the operation mode from manual to automatic. Switching between joint user and tool coordinate can be done simply by pressing the coordinate key. Press the button next to it to activate the external axis mode. Activating the single block function, the program will be brought to stop every time after running a line of command. To proceed to the next line, simply press start. Simulation mode is very useful when the user wants to examine the endpoint's coordinate value. The program will run at lower speed and the course of the program can be controlled with the forward and backward button. The override keys, on the other hand, control the speed of the robot arm movement. Teach keys are basically used to assign the type of motion and edit a command. Under the Program Edit page, press Select to call the command selection window. Press Select again if the type of motion is to be switched. Users also can utilize the Edit button to edit a written command in the program. Press Teach after done. Activating Shift button will enable the shortcut keys of Insert, Delete, and Execute. This provides an alternative way to edit the step of a command, other than clicking on the touchscreen to carry out these functions. When under the Command Selection button, our user can use the number pad to key in any digit. This includes negative sign, as well as decimal point. The general keys include functions, such as page and cursor changing, and call of online help. Please note these functions share the same keys as the jog functions. The general-purpose keys are only usable when the enabling device is let loose. The jog keys control the movement of the robot arm. By knowing which joint or on which axis to move, users can navigate the arm to the intended position. These keys are only activated if the enabling device is pressed. This will be covered further in the next part of this video. Before demonstrating the joint and endpoint movement, it's everyone's best interest to know what is the difference between these types of movement. Joint movement is basically rotational motion produced by the robot joint. As a 6-joint robot arm, there are 6 pairs of keys to control the rotational motion in both positive and negative direction. Joint coordinate is used to describe the position of joints. It's defined by the angle from each arm joint to the home joint. It should be mentioned that switching between types of coordinates is now done by pressing a single button. Click the coordinate button to switch between joint, user, and tool coordinates. To move the desired joint of the robot, press the coordinate button to activate the joint coordinate. Hold the enabling device while operating the jog keys. Contrarily, the endpoint movement is defined by the position of the flange with respect to the base coordinate system. Normally, more than one joint will be working to carry out the endpoint movement. To conform to syntax definition of the right-hand rule, hold the right fist, raise your thumb, and point in +X + Y and +Z direction. The rotation direction of the four fingers is the positive direction. To switch to the world or set user coordinate, press the coordinate key again. User coordinate is a self-defined coordinate that is usually located on the workstation rather than the base of the robot arm. This footage will show the difference in movement when selecting between the world coordinate and the user coordinate. As can be seen, the coordinate system now has been shifted to the working jig. When a tool is installed, such as a gripper or a deburring tool, the tool coordinate, which is initially located at the flange, can be shifted to the center of the tool at the end of the robot arm. By default, the tool coordinate system is located at the center of the flange. As can be noticed, the arm rotates about the A, B, and C axis, which can be defined as the rotation about the X, Y, and Z axis respectively. Switching to the tool coordinate, which has been taught beforehand, has shifted the coordinate system from the center of the flange to the tip of the deburring tool.